Hey everybody, this is Larry. This is me doing the weekly premium challenge. Week 3. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Seems like we're having a tree kind of day or two. Yeah, so let's do it. 1740. Find distance in a binary tree. Given the width of a binary tree and 200 P and Q, return the distance between the nodes of P and Q in the tree. Assume that the nodes are unique, otherwise it's a little bit awkward. Okay, they're both in a thing. The number of nodes in a tree in the range of 10 and 10. Okay, that doesn't matter as much. And this is not a binary search tree because that makes it a little bit thingy. So I mean, okay. So the idea here is it's another way of putting what you call it, LCA, lowest common ancestor, right? So the shortest path between two nodes in the tree. The shortest path is always going to be the simple path, right? Simple meaning that there's no loops, no self loops, no going over the same edge and stuff with all this stuff. And there's only one unique simple path. And of course, if you have a rooted tree, then it is just it becomes basically LCA, right? A lowest common ancestor, which has a variety of algorithms for kind of like if you have to answer multiple queries, then I would kind of recommend reading up on LCA. Maybe just like familiar yourself, even if you don't anyway. I think for me, I think binary lifting is a very cool concept in general. I always write it from scratch because it doesn't come that often for me to have a template. And I'm pretty slow at it to be honest, but it is kind of the whole the because the reason is that yeah, I mean I'm able to write it from scratch just from the idea in any language means that it's kind of a cool idea. Um, you know, you have to kind of be careful, but it's fine. Anyway, but you don't need this here, just to be clear, because you only need to do one query for one tree, right? So I guess that's the big difference. Big difference. Okay, so there are a couple of ways you can think about doing this. The way that I would think about it is maybe um, doing it recursively, right? Mm, yeah, I mean, I think that's basically the idea. Um, Basically, finding the. I'm trying to figure out how to explain it, but the idea here is that, as we said, it, one idea about solving this problem is about finding lowest common ancestor, and as a result, the lowest common ancestor is where another way to phrase it is where I guess one of the nodes could be the actual node, but but the other, but another way to phrase it if it's not the node that the root node or the subtree root node is that one of the nodes on the left and the others on the right, right? So that allows you to kind of play with some ideas. Still, there may be some edge cases, but yeah. Mm, okay, yeah. So I think the way that I want to write this, I don't know. I think I think the thing is that the reason why I'm hesitating a little bit and just kind of giving a little bit deliberate of a think is that it's very easy to write stuff that is n squared by accident. So I'm trying to be a little bit careful about it, but whatever. Let's just actually. I mean, yes, that's technically true, but let's play around with this and then we'll just go as we go, right? So another way to phrase this is that yeah, I mean the way that I want to say something like this is that maybe like count is equal to find node PQ or count left. Sorry, oops. Like I want to write something like this, and then basically if count left is equal to 2, then we just do like a recursion thing, right? But and maybe it's not even fine is another thing, right? So I don't know. But if you kind of do it this way and you do another recursive step here, that's where you get n squared. That's where, it's a little bit sketch. But the way that I would think about it is that if count left is not equal to 2 and count right is not equal to 2, and that means that this is the node, right? So then now, I guess maybe this is the root node, then that should be good. Then you just find the distance from this node, right? So find distance node MPQ, and then, but maybe, I mean, you could bubble this up with two returning two things, but I'm gonna be a little bit lazy and just kind of do it this way. Yeah. But that's basically the core of the concepts. Yeah. If node dot value, okay, so count is equal to 0. If node dot value is equal to p increment, and you could write this in a for loop, but I'm just gonna write it out. And then return count plus count left plus count right? But yeah, this also takes care. The reason why I kind of wrote this in a really awkward way is that this takes care of the case where one of the node is the current node and stuff like that. But yeah, so then now here you can just find root PQ and then return answer. Of course, we have to implement this thing, but that's okay, right? Yeah, and also we have to do like if node is none, then we return 0. Right, and then now we find distance is way more straightforward. So maybe I could actually, this should, I mean, you could write it this way, but and still whatever, but I'll write it as this, right? So this is maybe a little bit more straightforward or more easier to understand. Yeah, and then v for value, right? If node dot value is equal to v, then we return 0. Otherwise, then I probably could do this in a cleaner way. No, okay. I mean, I could do it this way, but I think the reason why I didn't want it to was so that I can do something a little bit yeah, I guess so. I don't know. No, I guess the other way is fine too. But then you do a little bit of duplicate work, but I guess there's only one duplicate work, so maybe that's fine. I don't know. It's kind of awkward because then now we're doing the entire tree at the same. I mean, and here maybe you don't even need to do it this way. Maybe you just do a breadth first search, but or level first search or whatever, and that would maybe have a better termination thing, right? So okay, just do it that way then. Fine. I don't know. The reason why I don't know is because a lot of these things don't really matter, to be honest. I mean, of course, during an interview, you have to be able to communicate and articulate your thought process and what you're thinking and why. But for me, to be honest, like neither of these things matter. Like I'll just be like, oh, you can do it this way, or this way. But honestly, all the complexities are mostly the same. You could say stuff about stack space or heap space or whatever, but it doesn't. I don't care about it enough. But yeah, and here we're doing a little bit of a duplicate work, but like I said, I don't care because it doesn't matter. Wait, is this right? I mean, this is technically right. Oh no, going downwards, this is fine. Now this is wrong though. It's only wrong because this is not returning early. Yeah, because then is that true? This is a little bit wrong. I'm doing like very awkward things. because like say at the base case level, that's just not going to be right. Right. Huh. What am I doing? How am I fixing this? Man, so what I'm doing now, I think I'm just doing, it's one of those things where when you have a wrong idea, it's hard to reset. I'm trying to think about how to make changes to it, but maybe I have to reset. I don't know. I'm okay, so you count left, you count right. Okay, fine. Okay, I think you need this, and okay, let's do count before, right? Total sub count is equal to count plus, or just this thing. All right. So do okay. So I think, and the sub count is equal to 2. I think then now we're good. Okay, because then that should only happen once, I believe. And then now we return. I guess now we can just return sub count just in case. I mean, now we return anyway, so I think that we're good. But okay. So then now this is just standard breadth first search, right? No depth is equal to right? If no dot value is equal to v, then we return d. Otherwise, for next node in no dot left, no dot right, if next node is not none, then q dot append next next node d plus 1, and that should be good. They should be found. So there should be assert force here, just to kind of, you know, like if we get to here, then we're really bad, because this should happen, or something I'm assuming is incorrect. Cannot unpack non-immutable tree node object. This is an oh whoops. Q dot append. Oops. Okay. Let's give a quick submit. If it's wrong, it's wrong. But I haven't done it before. All right. I mean, to be honest, part of the reason why this looks really funky and I took a while is because I was trying to not use heavy machinery. And I don't even really use the idea of LCA on this. I don't know if this is the cleaner solution though. It is kind of just like, you know, me building random stuff. But yeah. You know, yeah, I mean, this is all linear. I mean, everything was deliberately linear time, linear space, but it is all I have. Like I said, find just finds the node in which things fork, kind of, right? Like basically we know that both of these are in the subtree, but they're not on the same subtree, so then we don't, you know, otherwise you keep on recursing. Yeah, so we find the first spot that this is true. Yeah, and I think this is only true in one spot anyway. Otherwise then nothing holds. But yeah, and this is just a regular breadth first search. I could have done it recursively, but I was just like, let's play around a little bit. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.